All right, where's my example? Right there. Here's the function I'm going to take a look at. You may or may not have seen this before, depending on where you are on the homework. Limit as x approaches 0 of 1 plus x raised to the power 2 over x. First thing I usually do in a problem like this is I cheat and I ignore approach and I just plug it in. So if I just plug it in, so I'm going to just guess, then I'm going to get 1 plus 0 to the power of 2 over 0. And what's up with the power of 2 over 0? It's undefined. If I'm approaching from the right side, let's sneak that in there, then physicists like to say 2 over 0 equals positive infinity. And graphically, if we look at this, we can see that happening, right? So just a quick note on why that might be the case. Just think of the function y equals 1 over x. That's called a hyperbola. And it's got this shape here. It's got a vertical asymptote on the y-axis, a horizontal axis, asymptote on the x-axis, and then it's got this in the third quadrant, same idea. So if we're on the right side of 0, we get positive infinity. If we're on the left side of 0, we head toward negative infinity. Problem, infinity ain't a number. Okay, now, so that means one might say this right here is 1 to the infinity. Okay, on a good day, 1 to the infinity might be
1.
1. Like what's 1 to the 10th?
1.
1 to the millionth? 1 to the billionth? But is this number right there really 1?
No.
Because we're supposed to approach, right?
Yeah.
Yeah, so if we're not quite at 0,
It could be like
that means this isn't quite at infinity, and this is a little more than 1. Right? So that might not equal 1. I don't know. So what does it mean? So in this case, I get 1 to the power infinity when I cheat. Just like 0 over 0, this is called an indeterminate form. It means I don't know what the answer is.
Yeah.
Okay. So side note, 1 to the power infinity is indeterminate. Indeterminate. Later in the course, we'll look at other indeterminates. Indeterminate. There we go. We already know 0 over 0 is indeterminate. So is 0 to the power 0. And there's a bunch of other ones out there that at first glance, it might exist, it might not. Yeah. All right. Well, what do we do in a case like this? We do one of two things. We graph it or we build a table of numbers. Let's start with a graph. Desmos, here we come. All right, so then I'm going to use function notation because then I can reuse it. I'm just going to call it f of x equals parentheses 1 plus x close parentheses raised to the power. And I can't remember, we might need parentheses around the power. 2 over x. Nope, it took it. So here's my function. Ooh, check it. There's some scattered dots on the other side. Interesting. Oh, it looks like something's happening at 0 there.
Crosses?
It crosses when, right, x equals 0 is the y-axis. It looks like it crosses the y-axis. But what if I type f of 0? Undefined. All right, so I guess I'm just going to zoom in there. Okay. Problem, unless somebody programmed how to look for a hole, Desmos just skips right over it.
Yeah, so there's this.
Yeah, so we don't know there's a hole there unless somebody programmed a way to look for it. So what I can see here is that it's somewhere close to 7.4. As I zoom in on that, 7.39, just a little under. But how does a computer graph? Does anybody know? How do you graph? Don't you make a table of numbers?
Yeah.
And then plot a point, connect the dot, plot a point, connect the dot? That's how the computer does it. It just plots a shitload more dots than we do. Okay, so it's skipping, it doesn't know to plug in 0, or maybe it does, and it plugged in 0, so it was undefined and it just ignored it. I don't know if you remember, if you used TI-80 something calculators in the past, sometimes they would do a jump on certain windows when it found something like that accidentally, because it wasn't very good programming back then. Anyway, could I say it's about 7.39?
Yeah.
Yeah, looks like about 7.39. Does that ring a bell? What if I said it was 3.14? Would that ring a bell?
No.
3.14, you heard that number before?
Yeah.
Pi. Or what if we saw, like, anybody know the number 1.41? It's the square root of 2. What is it? It's the square root of 2, yeah. So sometimes we recognize a decimal as being a special number, but sometimes we don't. Are most decimals nice? Like think about 1 divided by 3. 0.33333333. That's not too bad, but it's a pain. 1/7. 0.142857, 142857, 142857, 142857. A little messier than 0.3, but some aren't that nice. Okay, so I have no idea what this number is. Okay, so what am I going to do? I'm going to try to approach it. How might I do that? Well, I'm going to pick a list of x numbers, x values that are going to 0. So I'm going to try that here. We could also do it in the spreadsheet. Anyone check out the spreadsheet I shared? I'm going to link it to this video for those of you watching this in the future. Hello, future for math friends. Yeah, the limit spreadsheet. So I'm going to whip that out in a second. So I'm just going to go f of 0.1, f of 0.01, so 1/10, 100th, f of 0.001, 1,000th, f of 0.0001, 388. Okay, so it's getting close to that 7.39 I was saying. Well, how close is close enough? We'll talk about that later. So basically what I do with a situation like this is I keep getting closer and closer to the number x value I want, and hope that I see some digits starting to get stuck. Like the 7 got stuck after the second try. The 0.3 got stuck after the second try. The 0.8 got stuck after the third try. And then I'm not sure about the third digit yet, right? That hasn't solidified yet. So I just keep looking. If somebody says you need 3 decimal places, then I'm going to keep doing this until I see it stable for a couple of tries. That's all we got. Unless we have some algebraic jiggery pokery that happens to work like the other day. I have no algebraic jiggery pokery for this at the moment. Well, that's a lie. I do, but I'm not going to show it to you till later. All right, so let's try another one. Do we have an answer here roughly? 7.39-ish to 2 decimal places. That's what we got. Okay. We don't recognize it as a special number yet. All right, actually, I'm going to play a game with you. I'm going to change the function a little bit. I'm going to take that 2 up there and make it a 1. One thing I learned in math is when you have a hard problem and you're not sure what to do, see if you can make it easier. Something might appear. So this easier would make that 2 a 1. Okay, 2.59, 2.7, 2.71, 2.718, 2.718. Does that number look familiar? That looks like E. Holy shit, let's check. Is that really E? E 2.71828. Holy crap. Oh. Doesn't my last check at, what am I at? Tenths, hundreds, thousands, millions. I'm at like a billionth there. No, tenths, hundreds, thousands, 10,000, 100. Okay, 1 million. F of 1 million is 2.71828, and then I lose track. This looks like it might be E. Well, E, it looks like it's the Y value, so we can't plug it in. We can't plug it in. But it looks close. I can guess it's E. All I can say for now is up to 1 millionth for X, I get 2.71828, blah, blah, blah. I have that much of E. Could it be it starts to not match later? Absolutely can happen. Yeah. All right, so I'm just gonna put a side note for this one right here. I'm gonna say the limit is approximately 7.39. That's all I know right now. That's with the 2 in the exponent. New page. The limit as x approaches 0 of 1 plus x to the power 1 over x appears to be about 2.71828, which looks to be about E, but I don't know for sure yet. If this problem was on your homework and you entered this, you would get it right. And if you entered this, the computer is just going to calculate E and compare it to what it knows as the decimal value and say, oh yeah, those look close. I'll give you credit for that. Yeah. So pretty much the way any problem you enter a number into works is the computer just does a comparison and say, are they close enough? Every once in a while, I tell it to make an exact symbolic match. Like you got to have pi in the answer, or you got to have a square root in the answer, something like that. But usually it's just a numerical, is it close? All right, that was exciting. All right, now I'm ready for homework questions.